And we are good to go. All right, so I'm good to go. Okay, so the goals are there on the packet at the bottom. Let's get started. Why is graphing so important? Yeah. All right. Listen, don't ruin my video. So let's go. I'm not trying to make this happen again. All right. So graphing. The reason why we graph is because we want to communicate with other people, right? If I want to communicate with someone very easily, what do I do? If I want to communicate with someone without words, what do I do? Not a text, a picture. Because some people don't even know how to read a text very well, right? So you use pictures. So graphing is important because you want to visualize data. If I show someone a picture, it doesn't matter if they don't speak the same languages as me, they're going to understand what the picture is saying. Okay, the next one, to pick out patterns. I already said a pattern. What's another word that I went over? Another word for a pattern is trend. Yes, trend. Yes. Miss Rodriguez? Amanda, Stefano. Aquí? Okay. That's it? Okay. Continue. Okay. And then to see relationships between variables much clearer.
Read the back? Yes, please.
Sit. My video. All right. See relationships between variables much clearer. Okay. Um, okay, a variable is a part of the experiment that changes. And there's always two variables for any graph, your independent and dependent variable. So again, we're doing these graphs because we want people to see a picture of what we're talking about. It can help pick out patterns. And you can also see a relationship between two variables. The word variable, by the way, this is the opposite of another word that we already learned. They are opposites. This is the opposite of the word constant. Okay, a variable is the opposite of the word constant. This actually makes sense a lot if you speak fluent Spanish, because I teach this class in Spanish as well. And the word variable in Spanish is variable. When something is variable, it means that it can change, right? A variable is something that can change. So you can think of it that way, something that is the opposite of a constant. And what you're looking at is, I want to see the relationship between these two things. I want to see if this thing will affect something else. And that's the whole basis of doing an experiment. Okay, so moving forward from here, you have two variables. You have your independent and dependent variable. Right here is an example of some data. Right, if you have some data like this, it's boring. People don't really find it interesting. It's kind of hard to understand. But as soon as you show people a picture, it makes them more interested. It's easier to understand. It's much more clear. Right, so the independent variable, this is what is controlled or manipulated by the scientists. So this is what the scientists can be able to change in the experiment. A good way to remember it, I control what's independent, and this is always on the x-axis. So the easiest way to remember this, if it's independent, it's in the bottom. Independent in the bottom. The next one here, the dependent variable. This is what is affected by the independent. It's affected by the independent. And this one is on the y-axis. Okay, so again, your independent variable is controlled or manipulated by the scientist, and dependent is going to be affected by the other one. And this is on the y-axis. Again, if you miss anything, you can just watch the video and go back if you missed any of the notes, because I am going to be going a little bit quick here. The next thing here, these are just some graphics to help you understand a little bit more about the independent and dependent variable. Right? Your independent variable is going to give you some kind of change. And that change will cause an effect on something else, which is your dependent variable. It's kind of like an English class. I don't know if they teach you this or what, but there's something called cause and effect. Let me do something, and then we're going to see the change. I'll give you a very quick example. I like to box as a way to work out. Not a professional boxer, but I like to box. I used to suck at jump roping. I was really, really bad. Really, really bad. And what I did was, I was like, how can I become better at jump roping? Practice wasn't really helping me, so I decided to watch YouTube videos. So I said, if I watch these YouTube videos, I think that I'm going to get better at jump roping. And it actually happened. So my independent variable is I started looking at the YouTube videos, and then the change was that I started being able to jump rope better. I can do like crisscross. I can maybe I'll show you one day if we do like an exercise lab or something. I can do a lot of cool things with the jump rope, but that's only because I made that change. If I never made that change, I would probably still be bad at jump roping, right? So that's looking at a relationship between two things. Here, this is a nice picture which shows you again where things should go on a graph. Independent in the bottom, dependent on the side. And let's move on, right? Graphs. Okay, graphs are helpful because they create pictures or visualizations. So I mentioned this before already. The reason why we graph is because it makes things easier to see. So another word for that is a visualization, when you're visualizing what's going on in the experiment, right? If you have this visual, now you can see trends, which are patterns or relationships that may exist within the data. That's pretty much what scientists do all the time. They just look at information and they try to figure out a relationship in order to make something better. That's what I did last year. Last year, I was like, wait a minute, why is it that every year our students are doing worse and worse and worse on the living environment test? What's going on? And I want to find out what's affecting it. So I looked at my data and I said, oh my God, all the kids that fail are level 1. No wonder, it makes sense. So I noticed a pattern. I noticed that the failures are all level 1s from 8th grade. I noticed that, and then I brought it to the attention of the department. I brought it up to the head and I said, hey, look, the kids that fail, they're all level 1. And she decided to say, okay, so if that's what's happening, now we can make a change to make it better so that less kids are failing. And this is kind of the way that the process goes, right? So that's pretty much why we would analyze our data, right? To try to make or improve something. Okay, adding a title to a graph. Okay, this is very simple. A lot of times kids ask me, Miss Santana, I don't know what to write as a title. I don't know what to do. Easiest way is look at your data table. Look at your data table and just copy down what's on the data table. Another way of doing the title is to use this sentence starter. The effect of blank on blank. That's my title. So the effect of an independent variable on a dependent variable. That would be a good title. We're going to do a lab. I don't know if tomorrow, yeah, probably tomorrow will be a good idea. It's going to be on the effect of music on your ability to do math problems, right? So I'm going to play different types of music, and I'm going to see how many math problems you can do with no music, with classical music, and then with hip hop, and see how that affects your rate. So that would be the title of our graph. Okay, decide on an appropriate scale. We talked about this. An appropriate scale means that you're counting by a specific number. All right, and if you're stuck on how to make an appropriate scale, scale is determined by your highest and your lowest values found on each side of the data table. This is also known as a range. So if you're not sure what number to go by, Miss Santana, I don't know what to count by, look at your highest number and look at your lowest number, and that can help you figure out what's the most appropriate amount to pick for the appropriate scale to be able to add that there. Okay, and then here, relationships in a graph. Okay, analyzing relationships in a graph. Nope. You can watch the video. Right, relationships or trends. You can copy down the word trend. Okay, relationships or trends in the graph. So when interpreting graphs, you are basically making an observation as to how the independent variable on the x-axis is responding to it should be dependent variable on the y-axis. That is a little mistake there, a little typo. Okay, so when interpreting your graph, you're making an observation as to how the dependent variable it should be independent on the x-axis is responding to the dependent on the y. So just fix the typo on the paper. I apologize. So you fix this on your paper. Okay, when we have three graphs here, we have A, B, and C. Let's look at A. Look at A. Is there a relationship in A between the population and the time? Is there a relationship there? No, there's no relationship. How do you know there's no relationship? How do you know there's no relationship there? Because why? There just isn't? No, there's a reason. Can anybody tell me the reason why there's no relationship? Dayanara? Nothing changes over time. What are you looking at specifically? The line. Thank you. The line is not changing over time, right? So here, over time, the population is not changing, so there's no relationship or no change. Okay, there's no relationship and there's no change. If you look at B and C, there is a relationship. Look at B and C. What's the difference between B and C? They're both showing increase, but they're showing increase in a different way. Look at B versus C. Christian? What do you mean goes up? What about the line goes up? What is that called? The slope, yes. The slope is very steep. Okay, the slope here is very steep. Versus here, the slope is a little bit more steady. So which one is happening faster? Is B happening faster or C happening faster? B is faster because the slope is steeper. Okay, so population increase quickly. We're copying. Population increase quickly over time. And then C, the population is increasing, but it's more steady over time. So it's a steady increase, or a gradual. Yup, you can use the word gradual. Good word. Okay, gradual or steady increase over time. Next week, I'm definitely giving you a test. Probably on Wednesday, I think would be a good day to give you a test. And it's going to include scientific method and graphing, and it's going to be all Regent style questions, all multiple choice, no vocab, none of that stuff. So it's going to be a little bit more challenging. Okay, last but not least, actually not last but not least, the bar graphs, right? So we use bar graphs when we have different groups or different categories. So if it's just one thing, we're going to use a line graph. If it's multiple things, like different groups of people or different groups of whatever it is, you would use a bar graph. So for the bar graphs, they are used to compare the frequency or how often something happens for different categories or groups. For example, when we do our experiment on the different types of music and if it affects how you do your math problems, that is different types of groups. You have a group with no music, a group with music, a group with a different type of music. So you would use a bar graph there. If you were just looking at one thing, like if this particular type of music, like classical, you could then use a line graph. But when you have categories, you use the bar. And also, if you look at the picture on the board, how come in some bar graphs we put a little space in between, and in some bar graphs we don't? Right? So if a bar graph has averages on it or a number range, you don't put any space in between. But if you're just comparing things, then you would use the space. Okay, here, the next page, we're looking at the water temperature change. Okay, right now I want you guys to do this page. The independent variable is blank and the dependent variable is blank. And write y. Just write y. Well, how do you know which one's independent and how do you know which one's dependent? So take a moment to do that. 1 second. All right, going back. So class, what is the independent variable? Oh, Jesus Christ. Come on, everybody. Heating time. Thank you. All right. And why is heating time independent? Because it's in the bottom. Thank you. All right. The dependent variable is going to be, oh my God, this video is going to be terrible. Temperature, right? And why? Because it depends on the heating time. Okay, the relationship between the two of them, the relationship. So as heating time increases, the temperature increases. So if you didn't have your relationship sentence filled out, that's it. Heating time and temperature are my two variables. So I'm going to put a box around them. These are my things that change. This one's independent. This one's dependent. Oh, we don't have a break. Nope, we're not done. We are not done. We need to finish this last one. If you guys were talking less, then you would have a break. Okay, data tables. So blame your classmates that talk. Okay, data tables. Okay, the first column is used for the independent variable. Your data tables are used to organize your data that would be plotted in a graph. So this is before the graph. You usually do this. Organize your data before the graph. Remember, the first column is for the independent. The second column is for dependent, ID. We talked about that already. Each column should be titled and include units of measurement. And the last thing, I talked about this already, you must put it in order. So ascending or descending, I wouldn't even worry about those words. Ascending means going up. Descending means going down. The most important thing is this word. Put them in order. Put those numbers on the independent variable in order. Okay. And that is it. For tomorrow's due now, you are to complete that data table in order for tomorrow's due now. So I'm just going to stop the recording so that I can put this up online.